Section 8.2, question E33, and we have this question about ghosts, which I think is pretty interesting. Again, I think this is real data here. So 36% respond that they believe in ghosts, which is over a third. So the question is it plausible that half of the United States believes in ghosts, assuming that our random sample, 36% of our random sample said they did, of course 64% that said that they didn't, we're assuming that. And our alternate hypothesis is that less than half would say this. What does that matter? Well, the two possible alternative hypotheses would be, one, the real percentage is different than 50%, or the real percentage is less than half. So different than 50% would be a two-sided test. Less than half, or if we had more than half as our alternative, either of those would be a one-sided test. And that will affect our critical value. So how do we find that? Well, we have our sample size, our estimated proportion, the P naught, in other words, our hypothesized null proportion, the null hypothesis proportion. We can calculate the standard error. This is just the same formula we were using in the previous section, where we have the square root of P times 1 minus P, and did notice here that I had P hat in there, which I shouldn't. So, okay, this is the square root of 0.5 times 0.5, not this 0.36 here, because we're basing everything on assuming the null hypothesis is true. So even in our formulas, we want to use that null hypothesis value of the proportion. So we get our standard error, and then we calculate the lower and upper values here, and let's see, oh, and this formula also has a mistake, so I grabbed C7 instead of C6. Okay, so this looks much more what I was looking for. So notice that I'm not calculating a P statistic value, which is what the book does in the examples. What they're doing in the examples is perfectly fine, and you can and should use that also. What I want to do here is connect this information with section 8.1, where we were creating these confidence intervals. Now notice I'm creating this confidence interval around the hypothesized null proportion. So I'm going 1.96 below, 1.96 above. In other words, if the population proportion was truly 0.5, and we took all these samples of this size, we would expect to get between 47 and 53% of people saying that they believed in ghosts in most of the samples that we take. In fact, in 95% of the samples. We could also create this confidence interval around the proportion and then say, okay, well, we're going, say, between 33 and 39%. We're 95% confident that the true proportion falls in that range. Of course, there would be a little bit different there. We'd have to create a little bit different of a standard error there. But we don't have that. We have a one-sided. So using the one-sided, we go 1.64 standard deviations. Notice that's because we're putting all of our 5% kind of error room, type 1 error room, into the left side of our distribution. So we're subtracting 1.64 standard deviations from the null hypothesis mean, or the null hypothesis proportion, sorry, and that would give us 0.7422. What does that mean? Well, that means that if we were to conduct this many times, and if really 1/2 of the people in the United States believed in ghosts, and that was the correct proportion, then the samples that we got shouldn't have proportions lower than 47%. Very few of them would have lower than 40%, 47%. So if we were getting something like 36%, as we have in this question, that would certainly suggest that that null hypothesis wasn't very accurate, and we would reject it. In other words, it's not plausible that this null hypothesis that half believe in ghosts is true. So we would reject that and say there must be some alternative hypothesis that less than half of Americans believe in ghosts. Okay, so again, what you would do if you were using the books method, there's a formula in there that you would plug these values into to get a critical z value. You would then compare that to to a z-test statistic, which you would then compare to the critical z value, in this case of negative 1.64, and you would find that it's much lower than negative 1.64, which would also cause you to reject the null and say that it's not plausible to believe. So I just want you to know that there is this freedom to do it in either way. If confidence intervals resonated well with you, feel free to use them also in these tests. Now the nice thing about using the books method, it tells you how far outside, how far away from the null proportion you are. It doesn't just help you reject or accept, which this confidence interval really just more or less tells you reject or accept. It gives you a sense that 36 is quite a bit below 47, but it doesn't give you a precise proportion of samples that you'd expect to be that extreme or more away from the null hypothesis, if the null hypothesis is true. So again, just another way to approach these hypothesis tests.